Hello guys, let's talk about the CBSE pattern question exercises on sets. First question is asking us to write the given set in the set builder form. Now as you can see, each element in this set is following a certain pattern, a certain fashion in which the elements are kept over here. What is the fashion? In each of the element you can see the denominator is one more than the numerator. Denominator is one more than the numerator, denominator is one more than the numerator, and that is what is happening in each element. Moreover, numerator is only varying from 1 to 6, and therefore because denominator is one more than the numerator, denominator is varying from 2 to 7. How can you write this set in the set builder form? I am saying let A be the name of this particular set which has elements 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6 and 6 by 7. In the set builder form, I have to write a general rule of one particular element, right? Generally, how would I define an element of this set? I would define it as n upon n plus 1. Numerator is n, then denominator is n plus 1. That is what is the rule which is being followed by every element sitting in the set. If 1 is the numerator, 1 plus 1 is the denominator. If 2 is the numerator, 2 plus 1 is the denominator. If 3 is the numerator, 3 plus 1 is the denominator. 4 is the numerator, 4 plus 1 is the denominator. 5 is the numerator, 5 plus 1 is the denominator. 6 is the numerator, then 6 plus 1 is the denominator. So in general, n is the numerator and n plus 1 is the denominator, where n is actually a natural number. N is the numerator, 1, 2, 3, 4, 5, 6, these are the values which n is assuming. Correspondingly, 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, 5 plus 1, 6 plus 1. From 2 to 7, the denominator is obtaining the values. So n is actually a natural number, 1, 2, 3, 4, 5, 6 is a natural number such that n is 1, 2, 3, 4, 5 and 6. For these values of n, one by one when you will be plugging in this formula, you would be getting nothing but all these elements respectively. So you can write n upon n plus 1 such that n is in n and n is varying from 1 to 6. Fine, this is the set A in set builder form. Clear? Moving to the next question we have, phi is given to us. A is given to us as 1, 3, B is 1, 5, 9, C is 1, 3, 5, 7, 9. Insert one symbol among these two between each of the following pairs of sets. Let's pick up the first pair of set phi and set B. Set B is given as 1, 5, 9. What is the symbol which you would be inserting between phi and B? Empty set is contained in every set. No matter whatever this set contains as elements, empty set is contained in every set. So this is the symbol. You can write over here, obviously you have to write as empty set is a subset of every set. Fine. Next we have A and B. So A, which is equal to 1, 3 and B, which is equal to 1, 5, 9. Now, is A contained in B or A not contained in B? A will be contained in B if every element of A is also in B. Now, 1 is in A, 1 is in B, cool. 3 is in A but 3 is not in B. That means there exists one element in A which is not in B, therefore completely A is not a part of B. Fine. A will be a part of B if A's elements are such that they are borrowed from B. There are few elements borrowed from B. Now 1 is one of the elements borrowed from B. B has 1. But 3 is not in B, that means this other element of A has not been borrowed from B, that means this A is not a part of B. So I will clearly be saying that A is not contained in B as 3 belongs in A but 3 does not belong in B. For sets we use this symbol, for elements we use this belonging symbol or does not belong. Next I have A and C. A is what? 1, 3. C is what? 1, 3, 5, 7, 9. Is A contained in C or A not contained in C? A will be contained in C if each element is A is also in B. If each element in A is also in C, then A will be contained in C. That would mean that A's elements or set A has been formed by borrowing some elements from C. Well, set A has 1, set C has 1, set A has 3, set C has 3. That means out of these 5 elements, I have taken a group of these 2 elements and created a set A. That means completely set A is a part of set C because A's elements have been borrowed from C. Whatever is in A is also in C. Of course, there is more stuff in C, but whatever is in A, that much is definitely in C. That means A is a part of C. So, I will be saying A is a subset of C as for all x in A, x is in C. Whatever is in A is also in C. Therefore, A is a part of C. And next I have B and C. B is 1, 5, 9 and C is the same 1, 3, 5, 7, 9. Again you can see whatever is in B is also in C. 1 is there, 5 is there, 9 is there. That means out of so many elements of C, 3 elements of C have been made a group of and set B has been formed. That means set B is nothing but a part of C and therefore B is a subset of C. Whatever is in B is also in C, so B is a subset of C. As for every x in B, we have x is in C. Okay, whatever is in B is also in C. C may have more stuff, but if whatever is in B is also in C, that means B has been formed by basically borrowing few elements from C and therefore B is a part of C. So, B is a subset of C. Moving to the next question, we have A, B and C are 3 sets. A is belonging in B, that means A is sitting as an element in set B. Please mind it, belonging means here A is being treated as an element in set B and B is contained in C, so B as a set is contained in C. Is it true that set A as a set is contained in C as a set? If not, give an example. Well, I will have to define an A, define a B and define a C such that this thing holds true or is violated. Why don't you give it a thought and then we'll be back on this question. Okay, so in here as I was saying, A is a set which is being sitting inside B as an element. B is sitting as a set inside set C. Then they are asking, is A as a set contained in C as a set? See, if you take A as singleton 1, I am saying let A be singleton 1, B be a set consisting of singleton 1 set. That means set A is actually sitting as an element in set B. Apart from this, it has element 2. Apart from this, it has just element 2 and define C as 1, singleton set 1, element 2 and 3. In this situation, can I say that A is belonging in B? Then A, this is A because I can write B as A comma 2. So A actually is sitting as an element in set B. So clearly A is belonging in B. And is B or in C as a set? Is B contained in C as a set? B will be contained in C if whatever elements B has, C also has. Singleton 1 as a set B has, singleton 1 as a set even C has as an element. Apart from it, 2 is an element in B, 2 is an element in C as well. Whatever is in B is also in C and therefore B is contained in C. But is it true that A is contained in C? A will be contained in C if every element of A is also in C. The only element in A is 1. The only element in A is 1, but 1 as an element is not in C. Singleton 1 is a complete set, it is not an element. If something like this would have been there, then I would have said 1 is an element in A and 1 is an element in C. But this 1 as an element is not in C. But 1 belongs to A and 1 does not belong to C. Therefore, A is not contained in C. Fine? Singleton 1 is a complete set as an element in C. But one element, element 1, which is an element in A, is not an element in C. So therefore, if not given example, it is false. Why? Because this is the example. We have a set A, set B and set C which are violating that A is contained in C even when A belongs in B and B is contained in C. Clear? Moving to the next question we have, which of the following pairs of sets are equal? Justify your answer. The first one says X is the set of all letters in the word alloy. So X is what? You all know when I write set of letters in the word alloy, I am avoiding repetition, I am avoiding ordering concern. The ordering of elements inside the set is of no concern to me, right? And if I have repeated letters inside the set, that is of no concern to me. So over here you can see the letters, distinct letters are A, L, O and Y. So when I make the set of all letters sitting in the word alloy, that would be A, L, O, Y. And Y is, or set B is the set of letters in the word loyal. Set of letters in the word loyal. In the word loyal, distinct letters are L, O, Y and A. L, O, Y and A. Are these two sets equal? These two sets will be equal when X will be contained in B and B will be contained in X. Whatever is in X should be in B, whatever is in B should be in X. You can see A is in X, L is in X, O is in X and Y is in X. A is in X, L is in X, O is in X, Y is in X. Clearly, A is contained in B and L, O, Y, A as elements is in B, L, O, Y, A as elements are in X. So B is also contained in, I should write X is contained in B and B is contained in X. Therefore, X is equal to B. Moreover, you can see also that both these sets are same because the only difference that you can see in these two sets is that the ordering of the four elements is different and the ordering does not change the set. If you change the ordering of 2 elements or 3 elements, it doesn't change the set remains the same. And if you start repeating the letters inside the set, even the set doesn't change, it remains the same. Because ordering and repetition of elements inside the set makes no difference, it is irrelevant to us. Over here only the ordering is different and therefore the sets, as sets they are same, and the actual mechanical way to show is that one is contained in the other, and therefore both are equal. If I move to the next question, I have A as all those integers such that n square is less than or equal to 4. So if I talk about the second case, I have set A as all those integers whose square is less than or equal to 4. I know 0 is an integer, 1, 2, 3 and so on, minus 1, minus 2, minus 3 and so on. 0 square is 0 less than 4, 1 square is 1 less than 4, 2 square is 2 square is 4 which is equal to 4, that is allowed. 3 square is 9, it will go beyond, I cannot take 3. Minus 1 square is 1 less than 4, minus 2 square is 4 which is equal to 4, minus 3 square is 9 which is going to go beyond 4. So 0, minus 1, 1, minus 2, 2. That is my set A. B is all those real numbers which make this equation equal to 0, that means roots of this equation x square minus 3x plus 2. When I talk about x square minus 3x plus 2 equals 0, break the middle term, this is x square minus 2x minus x plus 2, x minus 2 minus 1, x minus 2, this is x minus 1, x minus 2 equals 0. So x comes out to be 1 and 2, set B is this. Fine. Now you can see if I need to show A is equal to B, A should be contained in B and B should be contained in A. Clearly right now you can see A is not equal to B. This has 2 elements, this has 5 distinct elements. How can they be equal sets? But mechanically, what are you going to write? 1 and 2 are in B, 1 and 2 are in A, and therefore B is clearly contained in A. But 0 is in A and 0 is not in B. minus 1 is in A, minus 1 is not in B, minus 2 is in A, minus 2 is not in B, which implies A is not contained in B, and therefore A is not equal to B. That's how you conclude about equality of two sets. Next we have, out of 500 car owners investigated, 400 owned car A and 200 owned car B, 50 owned both A and B. Is this data correct? Is this given data correct or not correct? Now I am going to define, say, set A as persons who owned car A, and set B would be set of persons who owned car B. Fine. This is the total car owners. Fine. Then it is given to you that 500 car owners were there. That means number of members in the universal set is 500. 400 owned car A. So persons who owned car A, that means number of members in set A is 400. 200 owned car B, so number of members in set B is 200. 50 owned both A and B. Both A and B means intersection of the two sets. Number of members in intersection of two sets A and B gives me the number of those people who owned both car A and car B. This is given to be 50. Is this data correct? In order to find this out, let's consider number of elements in A union B. By formula, you know this is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Number of elements in A is 400, in B is 200, in A intersection B is 50, you get 550. Now you all know, if I show you through the Venn diagram, this is A, this is B, that's my universal set. A union B is this. This is what? A union B. Clearly, A union B is always strictly contained in the universal set, or it is equal to the universal set, which implies number of elements in A union B is strictly less than number of elements in the universal set, or at the max equal to the number of elements in the universal set. But number of elements in A union B is coming out to be 550, and number of elements in the universal set is given to be 500, and clearly 550 is not less than 500, therefore data is incorrect. Is it clear? That's how you conclude about this. Next we have, show that A union B equals A intersection B implies A is equal to B. In order to show A is equal to B, I have to show A is contained in B and B is contained in A. Firstly, A is contained in B, I would be interested in showing. So I am saying let A be in A. Now inside A union B are those members which are either in A or in B or in both. If this member is in A, clearly it is in one of, at least one of A, B, right? If a member is in set A, that means it is at least in one of A and B. Therefore, it is going to belong in A union B. Inside A union B are those members which are in at least one of A and B. Because small a is in A, that means it is in at least one of A and B, so it is in A union B. But A union B is given to be equal to A intersection B, which implies A is in A intersection B. If A is in A intersection B, that means it is a common member of A and B. That means it is not just in A, but it is in B also. Right? It was in A, now it is in B. This implies A is contained in B. Because small a was arbitrarily chosen from capital A. That means every member which is in capital A is also in capital B, so A is contained in B. And the second thing, exactly in a similar fashion, if I take an arbitrary member from set B, then this small b is in capital B, that means it is in at least one of A and B. So clearly it is in A union B, which is given to be equal to A intersection B, which implies B is in A intersection B, that means it is a common member of A and B. If small b is a common member of A and B, that means it is in A also, in B also, it is already in B. So this implies it is in A. Now it was an arbitrary member from set B, which is now in set A, that means each member in set B is also in set A. So B is contained in A. Therefore A is equal to B. Next question we have, prove that if A and B are two sets, then A intersection B complement is A complement union B complement. This is utterly important. You know which theorem this is the De Morgan law. There's another law, that proof is not being asked over here. It's A union B whole complement is A complement intersection B complement. Right now we have to just show A intersection B complement is A complement union B complement. Left hand side is one set, right hand side is one set. To show two sets are equal, LHS is contained in RHS, RHS is contained in LHS. This is what I have to show. So firstly I have to show A intersection B whole complement is contained in A complement union B complement. Consider an element in this set. Let X belongs to complement of A intersection B. If it is in complement of A intersection B, complement of a set is all those elements which are not in the set. So if X is in the complement of A intersection B, this means X is not in A intersection B. Inside A intersection B are those elements which are both in A and B, which are common members of A and B. If X is not in A intersection B, that means it is not a common member of A and B. That means it is either in A and not in B, or either in B and not in A. So this implies X is either not in A or it is not in B. Because if it would have been in both, then it would have been in the intersection, but it is not in the intersection. That means it is not a common member. That means it is either in A but not in B, or in B not in A. Clear? If X is not in A, that means it is in A complement, because complement of a set contains those elements which are not in the set. If X is not in this set, that means it is in the complement, or it is in B's complement. That means X is in at least one of A complement or B complement. That means X is in A complement union B complement. So I had started with X is in A intersection B whole complement. Now X is in A complement union B complement, which implies A intersection B whole complement is contained in A complement union B complement. One part is done. Let's prove the next part. Okay. Second thing, I have to show A complement union B complement is contained in A intersection B whole complement. Let me take X in the left hand side set. Let X belongs to A complement union B complement. That means X is in at least one of A complement or B complement. This implies X belongs to A complement or X belongs to B complement. If X is in A complement, that means definitely X would not have been in A. That is why it is in A complement. Here X is not in B. That is why it would have been in B complement. Right? If X is either not in A or not in B, either it is not in A for sure or it is not in B for sure, that means clearly X is not a common member of both A and B. Either it is not in A or it is not in B, that means clearly it is not in both A and B. Very obviously, if it is not in both A and B, I am sure of, that means it is not in the intersection. If it's not a common member, it's not in the intersection. If it is not in a set, that means it is in that set's complement. If it is not in A intersection B, that means it is in A intersection B complement, and this implies A complement union B complement is contained in A intersection B whole complement. So I have 1, 2 by 1 and 2 we have A intersection B whole complement is A complement union B complement. Hence proved. Okay? Moving to the next, we have if X and Y are two sets such that X union Y has 50 elements. Let's just keep on writing. X union Y has 50 elements. X has 28. Y has 32. How many elements X intersection Y has? Obvious formula to be used. Number of elements in X union Y is number of elements in X plus number of elements in Y minus number of elements in X intersection Y. I know this, I know this, I know this, I don't know this. So I will keep it on the left hand side. Number of elements in X intersection Y is number of elements in X plus number of elements in Y minus number of elements in X union Y. Number of elements in X is 28. Number of elements in Y is 32. In the union it is 50. So it is 60 minus 50, which is 10. It is 10 members which are in X intersection Y. Easy enough? Next question we have. A college awarded 38 medals in football, 15 in basketball and 20 in cricket. So basically there are three divisions being made. 38 medals were awarded in football. So let me write F is set of medals awarded in football. Fine. 15 were awarded in basketball. So B is set of medals awarded in basketball. And you have then cricket, set of medals awarded in cricket. It is given to me that number of elements in set F were 38. Number of medals awarded in basketball were 15. And number of medals awarded in cricket were 20. If these medals went to a total of 58 men only, basically it's not set of medals, this is set of people who were awarded medals in football, set of people who were awarded medals in basketball and in cricket. So 38 in football, 15 in basketball, 20 in cricket. Now I am saying if these medals went to a total of 58 men only, that means if I total out the people who got the medals, the number is coming out to be 58. Football, basketball, cricket, if I total it out, it's coming out to be 58. That means F union B union C, this set has cardinality equal 58. Fine, because overall only 58 men received medals if I combine all the three games, and that means F union B union C is equal to 58. 3 men got medals in all the 3 sports. So F intersection B intersection C, number of elements in this set is 3. All the 3 sports, right? All the 3 sports. How many received medals in exactly 2 of the 3 sports? Let's just draw the Venn diagram. How many received medals in exactly 2 of the 3 sports? That's my universal set. 1, 2, 3. So this is football, cricket, basketball. If I talk about exactly 2 of the 3 sports, this portion is representing exactly 2 of the 3 sports, football and basketball. This portion is representing exactly 2 of the 3 sports, football and cricket out of the 3. And this portion is representing only these 2 sports out of 3. I need to find the number of people who landed here, here, here. I want to find the cardinality of this shaded region. Let me write this as D, this as small a, small b, small c. Small d is the number of members sitting here, small a is members sitting here, small b is members sitting here, small c is members sitting here. Fine. I need to find number of members who played exactly 2 of the 3 sports. That means I need to find B plus A plus C. I need to find B plus A plus C. B is the number of members who played football and cricket. C is the number of members who played cricket and basketball only, not football. And A is the number of members who played football and basketball, not cricket. So basically B plus A plus C is the number of those people who played exactly 2 sports out of the given 3 sports. Right? I need to find B plus A plus C, that is number of members in the yellow shaded region that you can see. That is my target. Clear? Now please come back. If I am given the number of members in F union B union C, clearly I know which formula to use. Okay, so number of members in F union B union C, recall the formula. It is number of members in F plus number of members in B plus number of members in C minus number of members in F intersection B minus number of members in B intersection C minus number of members in F intersection C plus number of members in F intersection B intersection C. Number of members in F is 38. Number of members in B is 15. In C is 20. In F intersection B intersection C I have 3, and then I am left with number of members in F intersection B, B intersection C, F intersection C. And here I have 58. This is what? 38 plus 15, that gives me 53. Let's add it up. 38 plus 15 plus 20 plus 3. 8 plus 5, 13, 13 plus 3, 16, and this is 76. Fine, and then I have to do 76 minus 58, which gives me 18. Why? Because I would be shifting this completely this side. I have number of members in F intersection B plus number of members in B intersection C plus number of members in F intersection C to be equal to this complete sum, which is coming out to be 76 minus 58, that is 18. Now what is this written? Number of members in F intersection B. F intersection B. It is this, number of members in F intersection B. See carefully, this is F intersection B. Number of members in F intersection B means D plus A, right? That is number of members in F intersection B. Then I have number of members in B intersection C. B intersection C is this portion completely. So B intersection C is actually D plus C. You can see this is C, this is D. This complete is B intersection C. So D plus C plus number of members in F intersection C. F intersection C is this. This complete is F intersection C. How many members are there? D plus B. This is coming out to be 18. Right? That means you have A plus B plus C plus 3D equals 18. What is D? D is actually number of members in F intersection B intersection C. D is the common portion of all the 3 sets, right? And this number is given to be 3. So if D is 3, then 3 times D is 3 times 3, which is 9, and therefore A plus B plus C is 18 minus 9, which is 9. So A plus B plus C is equal to 9. Your answer is number of people who play exactly 2 out of the given 3 sports are 9 people, because A plus B plus C is coming out to be 9. Is it clear? That is what we wanted to find, A plus B plus C, that is the number of members in the shaded region. Next I have there are 200 individuals with a skin disorder, 120 have been exposed to chemical 1 and 50 to chemical C2, 30 to both chemical C1 and C2. So let me write a set of people exposed to chemical C1, be a set of people exposed to chemical C2. The number of members in set A which are exposed to chemical C1 is 120 and number of members in set B is 50. It says that 30 are exposed to both C1 and C2. That means number of members in A intersection B is 30. Right? Find the number of individuals exposed to chemical C1 but not chemical C2. So this is my set A, that's my set B. Exposed to chemical C1 but not chemical C2, that means only in set A, not in set B. I want to find number of members in this shaded region. To find A is the set of those members which are exposed to chemical C1. Now I want to find the number of members which are only exposed to chemical C1, not chemical C2. That means which are only in A and not in B. That means which are lying in this shaded region. This shaded region, you know what is this known as? It is known as A minus B. From A I have removed the contribution of B, then this portion has come. So I need to find the number of members in A minus B. How do you proceed to find it? With the help of the given information. Let's see. I know A, you can clearly see complete set A. What is this? This is A intersection B. Now this much is A minus B, this much is A intersection B. A minus B union A intersection B is complete set A. Right, this is A minus B and this much is A intersection B. A minus B union A intersection B is set A. As A is A minus B union A intersection B. And A minus B and A intersection B are disjoint sets, there is absolutely nothing common in them. And A minus B intersection A intersection B. That means the common portion between them is an empty set, that means they are disjoint. This implies number of elements in A is number of elements in A minus B plus number of elements in A intersection B. And therefore number of elements in A minus B will be equal to number of elements in A minus number of elements in A intersection B. This will be equal to number of elements in A minus B. Number of elements in A is given to be equal to 120 and number of elements in A intersection B is given to be 30. So you get 120 minus 30, that is 90 as number of elements in A minus B. That means 90 people are there which are exposed to chemical C1 but not to chemical C2. Next I have find the number of members exposed to chemical C2 but not chemical C1. Exact same approach. Exact same approach. Right? Here the only difference would be I would be focusing upon set B rather than set A. So that's my set A. That's set B. Exposed to chemical C2 but not chemical C1. I wish to find number of members in this shaded region. Now what is this? This is actually nothing but B minus A. From B I have removed the contribution of A and clearly this is A intersection B. Fine. I need to find the number of members in B minus A. Again set B can be written as, if you focus upon this A intersection B portion, B minus A union A intersection B is set B. As set B is B minus A union A intersection B, and B minus A and A intersection B are disjoint sets. They are disjoint sets. Therefore, number of elements in B will be number of elements in B minus A plus number of elements in A intersection B. Nothing will be removed, they are two distinct sets which are disjoint. So number of elements in B minus A will be number of elements in B minus number of elements in A intersection B. To find out those people which are exposed to chemical C2 but not chemical C1, from all those which are exposed to chemical C2, I will have to remove those which are exposed to chemical C1 as well as C2. I will be left with just those which are purely exposed to chemical C2. Number of elements in set B is 50 and in here it is 30. So 20 is the number of members in B minus. So we have found out the number of members which are exposed to chemical C2 but not C1. Find out the number of members which are exposed to chemical C1 or chemical C2. That means if I need to find this out now, number of members which are exposed to chemical C1 or chemical C2, that means basically the question is to find out the number of members which are in at least set A, at least one of set A or set B. That means if that's my set A and that's my set B, I am being asked either they should be exposed to chemical C1 or chemical C2. That means I want to find out the number of members in here. What is this? This is nothing but A union B. So number of members in A union B is what I need to find. I know the formula very nicely of number of members in A union B. What is it? Number of members in A union B is number of members in A plus number of members in B minus number of members in A intersection B. Number of members in A is 120, in here is 50 and here is 30. From 170 remove 30, you get 140. This is the number of members which are exposed to at least one of chemical C1 or chemical C2. And that completes our discussion over the questions. Thank you.